Hey guys, and welcome back to my channel. Today we're going to be discussing chapter 2 of the grade 9 textbook, and we're going to be covering powers and polynomials. So, I wanted to cover an example where we have one term as x, right? And we basically want to simplify this expression. And what we have in this expression is x to the power of 7 times x to the power of 3, all of that over x to the power of 6. So what I wanted to first point out is that there are brackets on these two here, and we have each of these terms separate. However, they can be combined as one in a very specific way, right? Because I'll cover this in the next example, but with this example we have x and we have x here as well. So they're gonna combine differently to something like x to the power of 7 to the power of 3. That would combine different from this, right? So there's several rules that you want to know when it comes to simplifying expressions with terms that have exponents on them, especially when they are the same terms, right? We have x as the same term throughout the entire expression. So how we're going to start this out is, well, the rule you want to know here is that when you're multiplying two different terms that are exactly the same, the powers add up. So here we have x times x to the power of 7 times x to the power of 3. So what I mean by that is x, you combine it into one term, and they literally add up at the top there. So it becomes x to the power of 7 plus 3, right? As opposed to where I said here, where it's x to the power of 7 bracket to the power of 3, this would be multiplication, right? This situation would warrant multiplication between the 7 and the 3. But over here, when we're combining these two terms, since they're being multiplied and they're the same exact term, we can now combine them by adding the exponents, right? So this now becomes x to the power of 10 divided by x to the power of 6. As we said, right, these are the same terms, but this situation was multiplication. This situation is division here. So the rule that applies to this situation is you subtract. So it's going to be x to the power of 10 minus 6, right? Because now it's division. These two are in different situations. And you can actually rewrite this. You could go straight into it and just subtract, but you can actually rewrite this to become this. So we have x to the power of 10, and this can actually come up to the top. So when an exponent comes up to the top, you have to multiply the exponent by a negative, right? What I mean by that is, if you were to multiply by a negative, you just put it in brackets and then you put the negative in front of that bracket, right? So whatever you have as an exponent here, you raise it up, put it in brackets, and put a negative. Since it's only one term here, right, in the future you're gonna maybe deal with multiple terms if you're someone who continues math and does maybe engineering math or something like that, or calculus or whatever. You'll have multiple terms, right? You may have an expression at the top here as an exponent. So you want to understand that it's actually the negative is going in front of the entire term, whatever's in that exponent. So now, remember what we said, what we did over here. We added them. What happens when you add a positive to a negative? When you add a positive to a negative, you're adding, you're putting this negative on top of this positive. So it's going to have a negative effect on this positive number here. So simply put, it's going to be 10 minus 6. This number is becoming more negative when you add on a negative number to it. So now we have x to the power of 10 minus 6. And that simply can be stated as x to the power of 4. So that's your simplified answer for this question. Now I wanted to go into a more complex problem. We're applying the same exact rules, right? So let's just quickly write down what the rules we discussed in this problem were. So we know that when you're multiplying the same term, you add exponents on each term. And when you're dividing, you subtract. Okay, so these are our two rules here that we discussed, right? So now going into a more complex problem, we have x to the power of 4, y to the power of 3, and then we have x to the power of 3 and y to the power of 5 divided by x to the power of 5 times y to the power of 5, okay? All right, so in this situation, we notice right away that we have two different terms throughout the entire expression. So we have x and we have y throughout the entire expression. So over here at the top, all of these are multiplication. So it's x times y times x times y. So you can pretty much ignore these brackets in this situation. There's nothing that's being added, nothing that's being subtracted. It's just pure multiplication. So you can ignore the brackets. And the order of operations doesn't change, right? So in that case, any of these things can be multiplied by each other first. So what does that let us do? That lets us multiply x to the power of 4 times x to the power of 3. All right, it doesn't matter what you multiply first in this top section because everything is being multiplied and there's no preference when it comes to right? In terms of order of operations. So what we're gonna do is we're just gonna rewrite it so it's clear to see. So we have x to the power of 4, x to the power of 3. Just bring the terms together. Y to the power of 3, y to the power of 5. So it's a bit clearer for you to see. X to the power of 5, y to the power of 5. Okay. So here we have the two terms we combined, and according to rule number 1, when we're multiplying the same term, you add exponents on each of the terms. So that would give us, I'm just going to write it on this line here. That would give us x to the power of 4 plus 3, y to the power times y to the power of 3 plus 5. Then we go ahead and fill out the rest here. Okay, so this would give us x to the power of 7 times y to the power of 8 divided by x to the power of 5, y to the power of 5. Now, when it comes to multiplication and division, there's no preference in terms of order of operations. Either one can be done first. As you see, there's only multiplication and there's only division. Those two things. There's no addition, no subtraction. So rule number 2 says when you divide the same term, you subtract the exponents on each term. So what are the same terms? X to the power of 7, x and y. Those are the same terms. Now we deal with the exponents, right? So it's going to be x to the power of 7 minus 5 times y. This dot that I put here, that means multiplication, right? You'll use that in later years, but it's convenient when you're using it in situations like this. You don't have to draw an x here. It makes things confusing and also takes up room. So I just put a dot there. You're going to use that if you take physics in grade 12 or maybe even calculus or whatever the case may be. So anyways, we have y to the power of 8 and y to the power of 5 divided by y to the power of 5. So that's going to be 8 minus 5. And what we're going to end up with is x to the power of 2 times y to the power of 3. And that's our result for when we simplify this expression here. As we discussed, there's just two simple rules that we discussed here when it comes to multiplying and dividing terms that have exponents. Obviously, I mentioned that they have to be the same term. Even if this was a -2 over 5, or if it was like a fraction or anything, and that was also that same fraction, you could actually simplify it by using the exponents. All right, so it would be the same exact thing. If you replace x with anything, literally anything that you wanted to put in place for x, you could put it in and leave it inside a bracket, and it will simplify to the same exponents there. Oh, sorry. But yeah, it'll simplify to the same exponents. And the same process applies pretty much. It doesn't matter what you put in. Same process applies, but just the only one thing is that it has to match in terms of the term. Whatever's inside the x, for example, would have to be the same for each of them, right? And you can still use this rule, but basically that's the limit of it. You know, you only want to use it in situations where you have the same term and when you're multiplying uh, several terms together. Anyways, thank you very much for watching. If you have any questions, please let me know, and I'll be happy to help you out. All right, guys, take